Hi everybody. I have decided to do this video because one of my students who is very much interested in physics wanted to know the Maxwell's equations in electromagnetic theory. He realized that to understand Maxwell's equations, idea of gradient, divergence and curl is needed. So in this video I am going to explain what is gradient and its geometrical interpretations. In this video I am going to explain what is gradient and its geometrical interpretation. First, you consider a function of one variable. So it can be represented on a graph. Here variable is marked along the x-axis. When x is going on changing, value of the function will be going on changing. Now df by dx is called derivative. So it is the rate of change of the function with respect to x. That means when we change x by a small amount, how fast f is changing. So that's the meaning of this df by dx. So df can be written like this. Df by dx, if you multiply by dx, dx and dx will get cancelled. So it can be written like this. So you can get df. Now df by dx is a proportionality factor. So here rate of change of the function is less. So df by dx is also small. Here f is changing rapidly, so slope is more. Here slope is less. So it's a proportionality factor. When rate of change of the function is large, df by dx is also large. Here df by dx is small. Then df by dx will give you the slope of this graph. So this is the change in the function and this is the change in x. Now let us consider a function which depends on three variables. Example, temperature. Temperature in a room. So you consider a coordinate system in the corner of the room x, y, z. Corresponding to each point there is a temperature. So temperature is a function which depends on three variables. So here we have to find out the rate of change of temperature. Here how fast temperature is changing. Here answer, the infinite number of answer is there because you can move upwards, sideways, down, top, bottom, like that. There are various directions in which you can move. But so situation is complicated. But a theorem of partial derivatives can be used and you can write like this. dt is equal to dou t by dou x dx plus dou t by dou y dy plus dou t by dou z dz. When a function is depending on many variables, we have to use partial derivatives, dou t by dou x. So this is the rate of change of temperature with respect to x axis. Now using the dot product, this can be written like this. So dou t by dou x, x cap, so is a unit vector, x cap is a unit vector. Then dx x cap. So this x cap dot x cap, it is 1. So dou t by dou x dx, you'll get like this. So this with this, if you take the dot product, you will get this. So this can be written as the dot product of two vectors. This is one vector, x cap is a unit vector, y cap is a unit vector, z cap, so x, y, z. So this is a vector, this is another vector. So this can be written like this. Now for this we can write del t, that is gradient. This is an operator, del t. Then dot di, so another vector, del t, that is dou t by dou x. For this we are writing like this. So del t, this is an operator del, So it's called the gradient of temperature. For this we have written, so del T is dou T by dou x, x cap, plus dou T by dou y, y cap, plus dou T by dou z, z cap. Now for this di, so dot product. Now let us see geometrical interpretation of gradient. dt, that is change in temperature, is del T dot di. Dot product can be written like this. dt is equal to magnitude of del T, that is magnitude of gradient of temperature, magnitude of di cos theta. You fix the magnitude of di and search for maximum change in temperature. That will occur when theta is 0. You substitute for theta. When theta is 0, here cos 0 will be 1. So this will be maximum. That means maximum change in temperature occur when gradient of temperature points in the direction of I. Then the gradient of temperature points in the direction of maximum change in the temperature. Magnitude of the gradient of the temperature will give the slope in that maximal direction. So this is the gradient of temperature. Temperature depends on 3 variables, x, y, z. Now this is the operator called del. This is the gradient of temperature. Now x cap dou by dou x plus y cap dou by dou y plus z cap dou by dou z. So gradient is a vector. That means it will have both magnitude and direction. To have a better idea, I will give you an example. Suppose you are standing on the side of a hill, then look around. At one particular direction, steep will be maximum. That is the direction of the gradient. Then you measure the slope in that particular direction. That will give you the magnitude of the gradient. Here, actually what we are measuring is height of the hill. But here it is not depending on 3 variables. It is depending only on 2 variables. So we will have a better idea. So it depends on longitude and latitude at a particular place. So what you are measuring is the height of the hill. So gradient is a vector and it has got both magnitude and direction. I hope you have understood the concept. Thank you for watching the video.